All right, Algebra 1, Lesson 53, just a single lesson today. That's kind of nice. All right, we're going to talk about adding and subtracting polynomials. Before we can get into polynomials, let's talk about what a monomial is. A monomial is the product of numbers and or variables with whole number exponents. Okay? All right, so we should see the difference between monomials and not monomials. So we have up here examples of monomials, okay, single set things. Not monomials we find in down here below, okay? So the product of numbers and or variables with whole number exponents, okay? These that we see down here are not monomials because these have variables with non-whole number exponents, okay? Whole numbers, right? Those are those positive numbers, correct? Right down here, right? Not whole, because if we move it up, it's -1, okay? If we move it up, that's -3, okay? Let's see, we've got -2 showing up there, okay? All right, let's look at some other things. Let's talk about degrees of monomials. A degree of a monomial is the sum of the exponents of the variables in the monomial. A constant has a degree of 0, okay? All right. Now let's look at polynomials. Adding and subtracting polynomials. We want to know what a polynomial is. It is a monomial or the sum or difference of monomials. Okay? So anyway, polynomial with one term could be something like as if, for example, 6x. Okay? A polynomial with two terms would be 6x plus 10. Okay? A polynomial with three terms is a trinomial. Okay, we're beginning to see some of this. It's, you know, kind of like a quadrilateral, or sorry, not a quadrilateral, but a quadratic equation is an example of a trinomial. Okay? So the degree of a polynomial is the degree of the greatest term in the polynomial. For instance, in the trinomial that we see here, the degree is 2 because the variable with the greatest exponent is x. It has a variable of 2. Okay, the leading coefficient for a polynomial is the coefficient of the term with the greatest degree. So let's look at what is the coefficient of the monomial that you see in the chart. What's the coefficient? 6. Okay. What is the leading coefficient of the binomial? Okay, in our chart, what's the leading coefficient of our binomial? Somebody besides Caden. All right, go back to our definition of leading coefficient. The leading coefficient for our polynomial is the coefficient of the term with the greatest degree. 6. Okay, that's our leading coefficient. What's the leading coefficient of the trinomial? Nope. The leading coefficient. The term with the greatest degree. What is it? Nope. What is the leading coefficient of x squared? Because a leading coefficient is always a number. You've already eliminated 2 possibilities. There's only 3 to go with. What are you left with? What sits in front of a variable if I don't see anything there? A 1. So what's the leading coefficient? 1. Because x squared has the highest degree, right? The degree is the variable with the highest exponent. Okay, the highest exponent there is 2, which goes to the x, and the leading coefficient in front of it is, I should be able to hear a lot more voices than just Caden's. What's the leading coefficient? 1, right? Because x squared has the highest degree. Okay, so we see a leading coefficient here of 6, leading coefficient here of 6, leading coefficient here of 1. Okay, you follow me? All right. In the French, the term is savvy, right, which means do you understand? Hopefully you do. Okay. The standard form of a polynomial. is a form of a polynomial where terms are ordered from greatest to least degree. So that's why you see this trinomial ordered the way that you do. Really, we would see this written like this: x squared plus 6x plus 10. And it goes in order of degree from greatest to least, right? Because this has a degree of 2, this has a degree of 1, this has a degree of 0. Okay? Or really 1 but no variable. Really, it does have a variable, okay? But it has a variable. Let's fix some of this. All right, just so that we see and understand it. All right, so technically speaking, this has an, what is this exponent, or sorry, what's the exponent to x for 6x? 1, all right? And the exponent for x here is 0, okay? The x has an exponent of 0, making it 1, eliminating it. Does that make sense? So it should go 2, 1, 0, right? I could have a larger, something beyond a trinomial where it would be, let's say, 4x cubed minus x squared. Well, now the leading coefficient is what? What's the leading coefficient here? 4. And what is the degree? 3. So the degree is 3, the coefficient is 4. Okay? But standard form is always going to start with the variable with the highest exponent and go down in descending order in order. Does that make sense? So that's how we write these things off in standard form. To add or subtract polynomials, we combine like terms. Polynomials can be added vertically, okay, meaning that we can put one on top of the other, or horizontally, we can set them side by side and add or subtract. Okay? Most commonly, you see them done horizontally. Okay? But we can do it vertically as well. I believe that's the last slide. So let's take a look here. Okay. You guys have this in front of you. So hopefully you can maybe, if you can't see the board, and I know some of you struggle to see some of these things from the distance, but we want to find a degree of this monomial. What is the degree? 7, because A has the greatest exponent, giving it a degree of 7. Let's check the bottom. Let's make sure we're right. B, 7. Oh, okay. So we learned something. Made a mistake. The degree in this case is what? It's 11. How do we get 11 from this? 7 plus 4. So we add the exponents. Okay? That's giving me the degree of the whole thing. We don't just, now if there had been multiple terms, okay, but we're going to order this ahead of anything else that has fewer exponents. So we're taking 7 plus 4 is 11 here. Okay? Let's look at number 2. Hopefully I won't mess this one up. Okay? We want to write this polynomial in standard form. Then we want to know what the leading coefficient is. So where do we start? How do we start putting this in order? What thing comes first? The what? The greatest what? The greatest exponent. So what term has the greatest exponent? 12x to the 5th. How am I going to write that? Is it going to look like this? Negative, right? We take the term that's, or we take the sign that's in front of it, correct? All right, so we got negative 12x to the 5th, right? What's next after that? Plus 2x to the 4th. Very good. Thank you. Was that Caden or Bladen? Caden, okay. Let's see. What's next, Christian? Minus 5x cubed. Good. Into the 3rd is fine too. All right. Let's see, Jordan. What's next? All right. So you got 3x squared. Why minus in front of it? There's a negative in front of the 3x squared? It's positive because there is no negative in front of it, correct? Okay. Let's see. Abby, what's next? Negative 8x. Okay, good. Okay, McEwen, what do we end with? Negative 6. Okay, good. Standard form, 5, 4, 3, 2, 1, 0. Okay, so all that's right. What is the leading coefficient, Blayton? Huh? The leading coefficient? What does leading mean? Right? When you were in elementary school, did you guys have line leaders? Well, who was the line leader? How did you identify the line leader? If somebody, you ever passed another class that was going down the hall in order, right? They're all single file. How did you know who the line leader was? The first person, right? So the leader is the person who is out front. How do I identify the leading coefficient? It's in the front. So what's my number in front? Negative 12 is my leading coefficient. Okay? Looks like A is my, is that what you were saying? You were saying A as the answer. Okay, and then, all right. Yep, you're absolutely right. Okay, how we feel about things so far? We feel like we're kind of getting an understanding here. Now, if we were going to ask, what is the degree of this polynomial, what would we have to do? Is it 5? What is it? 5 plus 4 plus 3 plus 2 plus 1. Okay? All right. So possibly look at it like that. Actually, the degree here would still be 5.
C, because 3x and 5x squared flip and yours are.
So what we're seeing here is that the coefficients don't match. You're absolutely right. Because we go negative 12, 2, but then 3 and negative 5 are swapped. See how they pick really subtle things to change? Because we were looking at the coefficients and the leading we were looking at the exponents and the leading coefficient. We weren't looking at the individual coefficient terms to see if those were right. Very good. Okay, our answer is C. Okay. Okay. And it's just that easy to get it wrong, and I didn't even spot that, so thank you. Okay, that's anytime where we can spot where we might make a mistake, we want to make note of that. All right. Here we have some things that we can add, but the reason that we can add these things together is because all the coefficients have the same variables to the same degree. Okay? If there was anything different about the exponents or the variables, could we add these two things together? No. And the only things here that we can add together are the things that are like terms, correct? So what this shows is adding these horizontally. Could we show how to add these vertically? Okay. I'm going to show you how to add these vertically. So we have negative 6c to the 5th minus 3c minus 4 plus, okay, 5c to the 5th plus 2c minus 4. Okay, so that's how we would add them vertically. Okay, what is negative 4 plus negative 4? Negative 8, right? Okay, the same as negative 4 minus 4 is negative 8. What is negative 3 plus 2? 1, right? So it would just be what? C. Okay, but it's positive, correct? Okay, we do need to have a positive there because we have another term that's going to go in front of it. We need to know what we're doing. What's negative 6 plus 5? Negative c to the 5th. Okay? So negative c to the 5th plus, oh, did we mess something up? I am just on a roll with mistakes, aren't I? Okay, minus. Okay, minus c minus 8. So A is our answer here. Gosh. I'm glad all this is being recorded for posterity so future generations can know, like, man, wish I'd gotten Miss Dodson. All right. Let's see. I'm trying to remember what time you guys get out of here. Is it 31? It is 31. So we better stop right here. Sorry I didn't get through anything that's necessarily in your book, but hopefully we get a degree of understanding on this. Pay close attention on A, that you are adding those exponents. If you look at A, don't forget that Y has an exponent of 1. So if you're looking at that, just so that I did cover something that's in your book, A should have a degree of 9. Look at it real, well, if you get a chance, but A has a degree of 9. So you want to apply that principle whenever you're looking at B and C. Okay, all right, we'll talk to you guys later. We'll get this sent out to you.